All right, hey everybody, it's Cameron here at .text. Today I'm going to walk you through an example that we have in our cookbook where you can go from an image to a structured output like JSON, a regular expression, classification, etc. We're going to use vision language models, and then we're going to pass it through outlines, our library for doing structured generation, and then we're going to get some output out on the other side that extracts all of the relevant information from our receipt. So there's a cookbook example on our site where you can go play around with the code. We'll put that in the description of the video. But we're basically going to go from this receipt from where I went to Trader Joe's. I bought some protein bars and bananas and milk and stuff. Real bachelor example of a receipt. But we're going to go from this to extract what store I went to, the address, how much of each item I bought, the total taxes, how I paid, either debit, credit, cash, check, etc. And we're going to get the total value and everything like that. So we're going to basically end up with something that looks like this, right? We get Trader Joe's, the address, the number of units, all the protein bars I bought, taxes, stuff like that. And there's a little roast thing that I'll check on in a second. But let's go through the code. If you want to know more about any of this stuff, it's written up in a little more detail in our cookbook if you want to play around with it. But for right now, I'm just going to walk you through the code and kind of give you like a high-level overview. So there's some stuff you need to install. Again, that's in the cookbook. You'll notice here that I'm doing Torch 2.4.0. I've had trouble with 2.5. That's probably an issue with my system and my CUDA stuff. So if you've tested this, you may just want to remove the Torch constraint to see if it works with more recent versions of Torch. But for me, I'm just going to use Torch 2.4.0. Then we've got our miscellaneous imports here. I'm not going to go into too much detail on those because it's boring. But let's jump right into working with the vision model. So we have two vision models here that you can choose from. One is Pickstraw, one is Qwen2VL. Both of these tend to work very well. There's many other vision models, but these are just the two that we tried. And to use them, you basically have to import the model class. In this case, it's Qwen2VL for conditional generation. You can usually find this class in the documentation for that model on Hugging Face. So here we're going to specify our model. This is kind of the organization and model name tag, and then we're going to give it the model class, and then we're going to load this into memory. So when we call outlines.models.transformersVision, what that's going to do is go find our model. It's going to give it it's going to pass our model class to TransformersVision, and then it's going to do a few other things. So the main two I'll point out here is device map auto. Device map auto will basically look at what hardware you have available. So CUDA, CPU, some Mac stuff. I don't know Mac stuff, so whatever. I'm sure there's magic that's happening there. And then there's Torch dtype. Torch dtype, we're loading bfloat16. This is just smaller than the native float32 that the models are trained in. This will just kind of compress it, lower our memory requirements, make it a little faster, if a little imprecise. But typically people will load in bfloat16. Okay. The next part here is, because we're working with images, we need to be a little careful about what we pass to our model. So load and resize image, I'm going to skip kind of the details of this. But the overview is that we give it a path to an image on our machine, and then a max size. So this is basically the maximum height or width of a image that we pass in. If any side is larger than that, it'll shrink it down to where one side is no larger than 1024. And the reason for this is that having really high resolution images and passing them into your vision language model requires higher context windows. And that can make it really slow to run. If you don't have a lot of video RAM, then you'll run out pretty quickly. So this is just a way of making it run faster and kind of doing memory management so that we're not eating up everything on our GPU. Okay, so I've downloaded the Trader Joe's receipt picture that I showed you before, and then we're going to shrink it down so nothing is larger than 1024. No dimension is larger than 1024. And then we're going to start getting into defining the output, the shape of the output that we want to get from our language model using outlines. So the way that outlines works is you give it a class. This is a pydantic class. This inherits from base model. Base model is a pydantic object or a class that you typically import from. So we're going to give it a name, a quantity, price per unit, and total price. So as an example here, the name is banana each, price per unit 23 cents, and the total price is $1.61. So that's the thing that we want to extract. So after we run this, we're going to get item with these four fields, and you'll notice that quantity, price per unit, and total price are optional. And we've also specified the type. So string, name can be any string. Quantity has to be an integer. You don't usually buy 3.5 of something. This could be an issue if you have weights. I'm not totally sure. Haven't tested that. Price per unit here is float, as is total price. Maybe optional in the cases where a receipt doesn't report it. And then we're going to have kind of a bigger class called receipt summary. That's going to get the store name, store address, store number, if that's available. Then we're going to get a list of items. So that's this part here. When we look back at the receipt, we'll get a list of items that's banana each, Bear Bells, chocolate, Doug. I don't know what a chocolate Doug is, but apparently I bought one. Okay, so we're going to get a list of items. We're going to extract the taxes, the total. We're going to get the relevant date. Notice that this is an optional string. And we're just going to use the regex pattern here, where we basically say we must have 4 digits followed by hyphen, then 2 digits followed by hyphen, followed by 2 digits. This is year, month, day. And so outlines, when it sees this field, it must output year, month, day. Okay. You can do this other ways. You can actually constrain it to be a date time if you wanted to. But I just wanted to show how to do this with a regular expression inside of the field. Okay. And then payment method has to be cash, credit, debit, check, or other. Okay. So those are our classes. When we run this, we're going to get something. We're going to get a receipt summary back. We can do, and this is all completely programmable. You don't have to worry about random nonsense characters because outlines guarantees that you will get something in this shape. Okay. So then we're going to build this function. This is called a receipt summary generator. We're going to do outlines.generate.json. We're going to give it our model, right? That's Qwen2 in this case. We're going to give it our receipt summary. That's the thing we're telling it to generate. And then we're going to use the greedy sampler, which just selects the highest probability token. For like numeric extraction exercises like this, you want something that will do the same thing every time. And greedy search is always gives you the same exact token that's high probability. The default is multinomial sampling, which is random. It'll sample randomly from tokens that are available to it. Then we're going to do this kind of like set up the prompts here. This is basically saying the user has said there will be an image. And then we're going to give it, you're basically an expert extracting information from receipts, be as detailed as possible. Missing or misreporting information is a crime. Tell your language model it might go to jail if it screws up this receipt thing. And then we're just going to give it the schema. So the schema here, receipt model.json.schema. I'll show you an example of what that looks like. It's kind of this big thing that we use to determine what is a permissible value when we construct this receipt summary object. But it also helps the language model understands what it's about to print. I usually give the model an example of the schema or the raw JSON schema so that it knows what it's allowed to print. And then we're basically going to run we're basically going to load the tokenizer. And the reason we do this is because there's like special system props for every model, like user, image, system, stuff like that, and they change across models. but you can use the stuff that's in transformers to apply a chat template. So this will take our messages, which has an image in it and it has text in it, and it's going to convert it to the chat template that Qwen2 uses. Then we're going to add a generation prompt. So we can take a look at what this looks like after we run it through the chat templater. And it's like kind of ugly. So it gives you like, it starts the system image, your helpful assistant. It starts the image block, be as detailed as possible. You'll notice that it starts, it does vision start, vision end. This tells the model to expect an image right here. Then there's the schema, and then we end the user block, and then we start the assistant block. This tells the assistant to begin printing. And then we're going to pass that prompt that I just showed you, and then we're going to give it a list of images. You can actually give it a list of any number of images. If you have given it multiple images up here, we've only given it one image to expect, so we're going to pass in exactly one image. All right, so when we run that, actually here, let's see how long this takes me actually. So this will take a second depending on your hardware, but I'll show you another example while we're looking at it. Essentially, the thing we're going to get out is receipt summary. That'll give us the store name, the address, each item, the quantity, the total units. This example actually works pretty well. You'll notice something in here. First of all, this is actually correct. If you go through the receipt, you'll find that this pretty much matches exactly. The only issue is store number. I cut off the bottom part of the receipt because it had the last four of my credit card, but that part has a store number. So without it, the model has a hard time checking what the store number is, so it opts to print it instead. And I want to add this thing here at the end, just to show you what you can do is roast user for receipt. So what I'm going to ask them, I'm just going to put another field in here to ask the model to roast me for what I bought. And at the end of your response, please humorously roast the user for their receipt. So I'm just going to go through and reload this stuff and go ahead and generate it. But I want to show you how to do this, like add this roasting thing, because you can mix pure data extraction with arbitrary kind of qualitative standard language model responses. And I really enjoy that kind of stuff. So here's the prompt that's going to go in. You'll notice that we have at the end of your response, please humorously roast the user. That's what's going into our language model. And a previous version of this roast is, you must be a fan of Trader Joe's because you bought enough items to fill a small grocery bag, but you still had to pay a bag fee because I bought a bag because I didn't have any with me. Maybe you should start using reusable bags to save money in the environment. So that's kind of funny. It was able to see that I had enough stuff that would fit into a bag, and that I still bought a bag. So this is just kind of an example of what you can do with vision language models, and I hope this was informative to you. If you like this kind of format, please let us know in the comments. And thanks very much for watching. It was really good to have you. So play around with the cookbook and enjoy.